All right, so this first one asks for pieces. So USA Today poll asked a random sample of 1,012 U.S. adults what they do with the milk in the bowl after they've eaten the cereal. If I were going through this problem, as I read it, I would write that this is my what? So what letter? What would I write? What would I do? What would I say that is? So again, get in the habit of kind of marking as you go. Now, this one was electronic, so obviously it's a little bit different. But I'm trying to write population. I cannot write with the... Other respondents, 67% said they had, so this is my what? P-hat. Suppose that 70% of the U.S. adults actually do, so that's my... So whether you're actually, like, I know this is electronic, so you don't have it in front of you, but kind of get in the habit of, like, as you're reading through it, writing stuff down. Identify a statistic and the parameter. So we essentially already did this. But when I say, if ever I ask that question, I need you to write out statistic and parameter. Because I need to know which one is which. So which one is my statistic? Which one is my parameter? Which is? And that was all this problem gave me. Some people put lowercase n with statistic, and I think that is absolutely fine. The book doesn't count it as marking off that way, so I want to be consistent with the book.
Put lowercase n where?
Because it's a number that describes the sample. Okay. And I think it should be there, but they don't count off if you don't, because it's actually used within that. So I'm not going to count off for it. How do I find the mean of the sampling distribution of p-hat? What's my symbol for it? Which equals? Which equals? So that's all you had to do for that one. What's my symbol for standard deviation?
Oh, squiggly. Sigma.
Sigma of
p-hat.
Which equals?
Square root of p times 1 minus p.
This is why you need to differentiate. Which number do I not use in this equation?
26.
I do not use that because that is not p, that is p-hat. So I'm doing 0.7 times 0.3 divided by 10, 12, square root of that, and I get 0.0144. What actually also has to be there? So I have to check 10% condition to be able to say that I can use it because of 10% condition. So yesterday, because it was the beginning of doing it, I actually explicitly asked you, why can you use that? That's not usually going to be the case. What is 10% condition? Well, my lowercase n is what? Which is? So I'm saying that capital N has to be greater than or equal to, which in words is, there are at least 10,120 what? Which is right. So because of 10% condition, I can use that equation. So now here I'm checking for normal. How do I check for normal? How do I check normal?
You do NP greater than equal to. And you do N times 1 minus P greater than equal to.
So 10, 12 times what? Which gives me, what does that give me?
708 possible.
And this one, I'm doing 10, 12 times 0.3, which gives me 303.6. I'm going to need more room. There are at least 10 what? That what? That's just word for word for the problem. What else do I need there? Questions about that? So this one, we have everything that we need. We've checked all our conditions, so we've basically gone through all of state plan do, state plan, where it do. We've done part of do because it's found the mean and standard deviation. So now we're finding P parentheses what?
The P count is less than or equal to.
What do I do with that number? So what are my numbers plugged into the z-score equation?
Minus 7.
Divided by
0.044.
which gives us a z-score of
Negative 2.
so I'll rewrite that. A negative z-score is over here. Which way do I shade? Left because it's less than. You end up getting 0.0188 here.
That's your area.
As your area, as your answer, your probability there. But one point that I want to make here. This statistic, in all of this work, where does that number get plugged in? That's the only place that I use that number. I am going to have some people who mixed up when to use 0.67 and when to use 0.7, and they tried to probably use 0.67 through here or here. But that thing that we are trying to find the probability of does not get used at all until I actually plug it into my z-score equation. And that is the only place it gets used. Every other place in that, we're using the actual parameter p instead of p hat. Questions with the first one? Alright, so with this one about performance enhancing. What's the first part of state? What is our population here?
Total Division I college athletes.
What is our sample?
732 Division I college athletes.
That were
Asked if they think performance enhancing drugs are a problem in college sports.
and I'm saying the same thing just in a different way. The randomly selected Division I college athletes it said that were, it didn't say they were surveyed. It didn't use the word survey, right? So same thing, just Irish word is different. What else do I need to do here? Which is
Portion of it. All Division I athletes that basically belongs to their
I'm just doing word for word from problem here. What else do I need? What am I finding the probability of? So just like that last problem, when is the only place that I'm going to use 1/3? When I plug it in to find my z and do. All right, plan. What's my first condition? What is 10% condition?
In big N is greater than or equal to 10 little n.
What's my lowercase n?
750. There are at least 7,551 content.
What's my next condition? How do I check for that?
If he is greater than 10.
What's my n? What's p? So it's going to leave 0.7 for here. What's 30% of 750? Which leaves me what over here? There are at least 10 what?
do or don't believe.
I'm not gonna. Performance enhancing drugs are da da da. What do I have to end with there?
So we can use the whole solution. Instead of 0.3, I used 0.3.
That's why I was making a point here where, because you're not gonna be the only one who did that. We do not use this number anywhere until we get to do, and that's the number you're talking about.
But we just used it there.
That's 30.
Oh, okay.
And I always have people on the first day who get that mixed up. Questions with conditions. This is referring to our sample. All right, what's the first thing I do? Mu of p hat, which equals then
Sigma p hat
which equals
square root of p times 1 minus p right.
all right. So then this 0.3 times 0.7 divided by 750.
0.0167.
67.
Yes, because 2% commission.
So I've already checked it before that, so I don't have to change anything. I just have to write because I checked 10% condition and it works. Now what?
Probability.
So I'm finding p parentheses what? Now some people are going to leave this as 2250 over 750 or change it to 33%, whatever, that's fine. What do I do with that first? Convert it to a z. So what numbers do I plug in? And I get a z-score of
2.00.
oh, I used something. Okay, so
I got 1.7964.
79 shouldn't be right. But some people might get 1.99 if they used a rounded number here, like 0.3333, as opposed to 1/3, because that's cut off.
If you did 0.33, then you would get 1.8.
Alright, so let me go ahead and stop and make a point here. Is this the same as 0.33, which is the same as 0.33333? Like as far as writing, like we're all talking about the same thing, right? So the difference between just calling it 0.33, you get a z-score of what?
1.8.
If you do all the way to 4 decimals, you get 1.99. If you do it as 1/3 plugged in there, are these really far away? Is this one really far away? That's why I get so picky about 1 to 4 decimals at least.
So why?
It makes a huge difference really
Where'd you
quick.
get the 1/3 from though? Like this.
250 out of 750.
That's our population.
So for now, I don't care which one you used, but from now on, don't use anything less than 4. So either write it as a fraction and don't round, or write it to 4 decimals. So now that I've got my z, I'm rewriting it as p parentheses z is greater than or equal to my z-score. What do I do from there? So my z-score is positive, so it's over here. Which way do I shade? To the right says greater than. And I get an area of what with 2.0? What do I get with my area? Because I have it with 1.99. But you do 1 minus that. If you did it with 1.99, you get 0.0233, which is going to be even different if you use a different t-score. I'll type the conclusion part so you're going to have to read it.
Wait, did you do 1 minus?
If you type it in the calculator, okay. So let's while we're here, let's type this in our calculator. If you did, yeah, if you did yellow sheet or something like that, you'd do 1 minus. If I use the calculator to do it, and I get here, it prompts me with a lower and an upper. So in this case, what would I put as my lower? What's the lower bound of the shading part? 2. So I'd put 2.00 in the lower, but what would I put as my upper? 1E99. So I talked was close to positive infinity. So 1, the E is the second comma, which is above the 7. If you forget that and you type a whole bunch of 9s there, you're going to get the same thing.
If you just do 9.
Mm-hmm. So if I do it with just a whole bunch of 9s like that, I'm going to end up getting this, which was the same thing that we got. Questions with calculator. All right. So our conclusion would start with what? We were to randomly select what? And what? Would what? And 0.02, what was it? 28. This part gets pretty much exactly repeated here. Remember I told you that it's going to be essentially restating the same thing, but as an answer instead of question. So choose word for word from the problem. Questions on homework?